Now I'm going to show you how to convert from base 10 to octal. Much like binary, you start by dividing the base number by 8. Instead of 2, we use 8. And then we get the remainder. 348 divided by 8 is 43.5. And remember, to convert the fractional part into a remainder, you just have to multiply it by our divisor, which is 8. So 0.5 times 8 is 4. Then we take our 43 and then we divide that by 8 again, which is going to be 5, remainder 3. And you can actually just mental this because 8 times 5 is 40, and when there's a 3, that's our remainder. Now we're going to get our 5 and divide that by 8. And now we're going to get 0, remainder 5, because we can't really divide 5 by 8. It's just going to look like this. So 5 is going to be our remainder. And much like binary, we read it from bottom to top. So we're going to list that down to 5, 3, and then 4. That's our base 8. Now I'm going to show you how to convert this back into base 10, and then I'm going to show you a little trick to convert that a little bit easier instead of using this method I'm going to show you. Okay, so when converting from octal to base 10, we start from left to right. And much like binary number systems, we have to imagine it's starting from 0, 1, and then 2 over their heads. But instead of using 2 as the base, we use 8 because we're using the octal system here. So let's try. That's going to be 4 times 8 raised to 0, 3 times 8 raised to 1, then 5 times 8 raised to 2. So 4 times 8 raised to 0, that's just going to be 4 because 8 becomes 1 here. 3 times 8 raised to 1, that's going to be 24. Now our 8 squared, that's going to be 64 times 5, so 320. And then if you add these up, that's going to become 348. Now I'm going to show you the faster method, in my opinion. So if you're familiar with octal to binary, you should know that the binary numbers are actually lined up in groups of 3. Like so. And they count from left to right like this. And these are just represented again in binary as 1, 2, and 4. 1, 2, and 4. 1, 2, and 4. And we can apply the same concept for each digit in the octal number. So let me just show you that. So let's start with 4 here. 4 represented in binary is just going to be 1, 0, 0. Remember this. And then 3 represented in binary is going to be 0, 1, 1, because 2 plus 1 is 3. Then our 5 is going to be represented as a 1, 0, 1, because 4 plus 1 is 5. Remember this. Okay, now that we have our binary number here, what we can do now is recall that it goes from 0, 1, 2, 3, 4, 5, 6, 7, and then 8. Using this information, and then remembering our powers of 2, we can just add these up together. So 2 raised to 8 is 256. 2 raised to 6 is 64. 2 raised to 4 is 16. 2 raised to 3 is 8. And 2 raised to 2 is 4. So 256 plus 64 plus 16 plus 8 plus 4 that's going to be equal to 348. As you can see, we had the same answer here and here. So you can use any of these methods to convert from base 10 to octal to binary. I guess I already showed you a method to convert that to binary real quick.